These are the examples for exponential and logarithmic equations. So let's just start off with examples. Number 1, we have 4 to the x plus 2 equals 16 to the x minus 3. So there are several ways that we can do this problem. One, we can get the bases the same. So this is 4 to the x plus 2. We've kind of already done this a little bit. 16 is 4 squared. The other option is to put it in log form on both sides, but we'll do that on another problem. So if you can get the bases the same, do it that way. You can also take the 4 and the 16 down to 2 if you want. That gives me 4 to the x plus 2 equals, you're going to have to distribute the 2 times x and your 2 times negative 3. That's 4 to the 2x minus 6. Once your bases are the same, you can set x plus 2 equal to your 2x minus 6 and solve. So subtract my x. It gives me 2 equals x minus 6. Add 6. That gives me x equals 8. Number 2. I have 1/3 to the n equals 1 over 81 to the 2/3. So my goal is to get my bases down to the same thing. Either both to be 1/3 or I can make them both be 3, but I can always break 81 down to 9 times 9, 3 times 3, 3 times 3. So this is 1/3 to the n, and 81 is 3 to the 4th power, which gives me 1/3 raised to the n equals, I'm going to multiply this 4 and the 2/3. So my 4 times 2/3 gives me 8/3. So this is going to give me 1 over 3 to the 8/3. And as long as my base is the same, my n equals 8/3. Log base 4 of m minus 3 plus log base 4 of m plus 3 equals 2. Anytime that you have two separate logs, if you're going to solve, you need to condense these into one. So since this is multiplication, since this is addition here, I need to multiply these two together. That's going to give me log base 4 of m minus 3 times m plus 3 equals 2. Since I don't have a log on the right-hand side, I'm going to have to rearrange into exponential form. So that's going to give me 4 squared equals m minus 3 times m plus 3 is m squared minus 9. That gives me 16 equals m squared minus 9. Add 9, I get 25 equals m squared. And keep in mind, when you take a square root, you need to put a plus or minus in front. However, we're going to need to double check these. If I plug in a 5 here, 5 minus 3 is 2, that's fine. 5 plus 3 is fine. But if I plug in a negative 5, that's going to give me negative 8. You cannot have a negative number as your argument. So that negative is out. So your answer is only going to be positive 5. So be careful of extraneous solutions. Okay. Example 4, natural log of x equals 6. If you remember, natural log is log base e. So if I rearrange this, that would be e to the 6 equals x. And if you put e to the 6 in the calculator, that's second your natural log button to the 6th power your x is going to be approximately 403.4. So that part would be on a calculator. If I were to put this on a non-calculator part of the test, you would just leave e to the 6 as the answer. So it just depends on what kind of part or what kind of section you have on your test. Number 5. 7 minus, 3 log 10x equals 13. So my goal right now is to get the log by itself. So I'm going to do that by moving my 7 over. That gives me negative 3 log of 10x equals 6. Divide by negative 3. That gives me log 10x equals negative 2. Okay. Then remember, this is understood to be base 10. So you can do one of two things. I can either split up log of 10x, or I can just rearrange this. This would give me 10 to the negative 2 equals 10x. Okay, and so if I divide this side by 10, 10 to the negative 2 is 1 over 100 divided by 10. Is going to end up giving me 1 over 1,000. Okay, number 6. Log base 5 of x to the 4th equals 20. Okay, so you have two options. I can either move the 4 to the front, or I can rearrange. But I'm going to move the 4 to the front. It might make this problem a little easier. So this is going to give me 4 times log base 5 of x equals 20. Divide both sides, not by 5. Divide both sides by 4. That gives me log base 5 of x equals 5. And then it's a little bit easier to rearrange. Your numbers are not so big. So base 5 to the 5th power and equals x. And 5 to the 5th power, 5 times 5 times 5 times 5 times 5 is 3,125. So remember, that's 5 times 5 times 5 times 5 times 5. 5 to the 5th power. 7 log base 2 of 5 equals log base 2 of 10 minus log base 2, that's really a bad log. Let's try that again. Log base 2 of x minus 4. So I'm going to condense this side into one log. Since this is subtraction, I'm going to divide the 2. That's 10 over x minus 4. I'm going to leave the left side alone. Now, once both sides have a log, I can just set their two arguments equal to each other. The logs don't matter in this case. So my 5 equals 10 over x minus 4. Multiply both sides by x minus 4 to get rid of your fraction. Distribute the 5. That gives me 5x minus 20 equals 10. Add 20 to both sides. That gives me 5x equals 30. And when you divide, you get 6. So I'm going to double check. If I plug 6 in here, 6 minus 4 is 2. That's okay, as long as this is positive and not negative or a 0, then 6 is my answer. 8 log base 5 of x squared plus x equals log base 5 of 20. So again, I have logs on both sides. So I'm going to set x squared plus x equal to 20. Since I have an x squared and an x, we're going to have to move my 20 over to the left side and factor. And yes, you need a factor. So my x is negative 5 or 4. However, if I plug in, let's double check. If I plug in 5 here, that's going to give me negative 5 here. I'm going to get 25 minus 5, which is fine. So even though you get a negative number, when I plug it back in here, when I plug it back in, 25 minus 5 gives me 20. That still works. If I plug in a 4, 4 squared is 16. 16 plus 4 is 20. This also works. So there's two answers, negative 5 and 4. So you just have to make sure that once you plug it back in, you don't get a negative number. Just because it's a negative number doesn't mean that it's necessarily eliminated.